All right, this is lesson 1.4, and we're going to be solving linear equations. And so steps in solving linear equations, typically you want to start out by simplifying each side of the equation, which means maybe using the distributive property or combining like terms. And after that, you want to isolate the term that contains the variable. So get that term by itself and everything else on the other side. And then lastly, you want to isolate the variable, get the variable alone. So keep that in mind as we're solving. So step one, we're going to simplify each side here. So on the left side, we need to distribute to get rid of the parentheses. So 10 times x minus 10 times 5 is 50 equals 12. And now this is your variable term because the x is in this term, so we want to isolate that. So we're going to get rid of negative 50. And in algebra is when we have an equality, if we do something to one side of the equality, we have to do it to the other. So if we add 50 to this side, we have to add 50 to the other side. And now it's still balanced. So we have 10x is equal to 62. And now, lastly, we have the x right here. We want to isolate the variable. So right now, the x is getting multiplied by 10. So the opposite of multiply is divide. So x is equal to 62 divided by 10, which is 6.2, or you could reduce your fraction and leave it in fraction form too. All right, in the next problem, we need to first simplify each side. So we have two parts here where we're going to have to distribute. So we have 12x minus 18, and this is like a negative 1 right here. So we have negative 1 times this, negative 1 times this next term. So that would be negative 6x minus 1 equals 10x. And we have to first combine like terms because on the left you have 12x minus 6x. So really what you have is 6x, and minus 18 minus 1 is a negative 19, and that equals 10x. Now we have a variable on each side, so it doesn't matter which side we choose to get them all in to be on. It would be one less step if we just subtract 6x from both sides. So the x's cancel on the left, so you have negative 19 equals 4x. And if we divide by 4, x equals negative 4 and 3/4, or you could also leave your answers negative 19/4. All right, now in this next problem, we have some options, and we're going to use a strategy to kind of make the problem a little bit easier in the long run. If we were to distribute, you would have 2/3 times 5, which would be a fraction, and we would be working with fractions throughout the whole problem. So one strategy I like to use is you have 2/3 times something, multiply by whatever's in the denominator. So multiply this side by 3, which is actually 3/1. And then if you multiply one side by 3, you have to multiply the other side by 3 to keep it balanced. And now 3 times 2/3, the 3's cancel. So what you have is 2 times x minus 5 equals 39. And so that just made our problem a lot easier, I think. So first we distribute, and then we add 10. So 2x equals 49. So x equals 49 halves. And you could write that as an improper fraction if you want to, or as a mixed number if you want to. This is an improper fraction. Now, just a quick review here. When you have 3x minus 2 equals 7, you wouldn't first go and multiply the 3x times something. You would first get the 3x by itself. So you first have to add 2 to both sides, and then you have 3x equals 9. And so x would equal 3. I need you to remember that when we do the next problem, because in this problem, you have your variable term right here, but then you have the plus 2. So before you can go and multiply by a 5, you want to subtract 2 from both sides. All right, now at this point you have 4/5 times x minus 10. So at this point we have two factors here. So we're going to multiply by 5 and by 5, because 5 is the number in the denominator, and so that will cancel. So you have 4x minus 10 equals 25. Then you distribute, and we continue to solve. So 4x equals, let's see, 4x, I gotta erase that. Four x equals 65, and then we can divide by 4. So x equals, let's see, 4 goes into there once. Is that 16 and a fourth? I think so. All right, next problem, solve for x. Now, here we have an expression divided by 4. So whenever you have an expression, which means you have a term, and you're adding two terms or subtracting terms, put parentheses around it. Now, these go together, so you can't just go and cancel these 4's, because this 4, negative 4 goes with the 2x. They belong together. So first thing we're going to do is get rid of fractions. So we're going to multiply this side by 4, multiply this side by 4. So the 4's cancel, and now we don't have to worry about that fraction anymore. And then you can add 4 to both sides. So x equals 42. All right, in this next problem, again, we have a fraction, but there's an expression on top, so I'm going to put parentheses around it. There's an expression on the other side, so I'll put parentheses around that too. So let's multiply by 6 to get rid of the fraction here. If we multiply the left by 6, we have to multiply the right by 6. So you have 2x minus 4. And over here, 6 is getting multiplied by the whole side, so you have to distribute it. So you would have 6y plus 120. So if we add 4 to both sides, you'd have 2x equals 6y plus 124. Now we are solving for x in this problem. So now, at this point, we have a few options. You could just divide both sides by 2. And so you'd have x equals 6y plus 24. But that's not the simplest form. Now, one way to easily get it into the simplest form is when you divide something by 2, a side by 2, you have to divide the entire side, all of the values by 2. So if you just write each term divided by 2 and simplify each of the terms, that will put it in simplest form. And that would be your answer in simplest form. X is equal to this. All right, next problem. X is in this expression here. So first, let's isolate this variable expression. So we'll subtract 3 from both sides. And now at this point, I'll put parentheses around that. Multiply by 2 to get rid of fractions. And then we can just solve. Isolate the variable term, so get rid of the negative 3 by adding plus 3. And lastly, divide by 4. So x equals 11/4 or 2 3/4. All right, now we're going to solve an equation, a literal equation, where we just pretty much have letters, and this time we're solving for x. Now, there is an x in both terms. So the way that we do that is we have to factor an x out of that expression. And factoring is the opposite of distributing. It's instead of multiplying when you distribute, you divide it out. So the x comes out front. Ax, if you divide by x, would be just an a. Bx divided by x would be just a b. Now keep in mind, if you have x times a plus b, if you were to distribute that, that would be x times a, or a times x, and that would be x times b, or b times x. So it's just backwards distributing. Now the x is out front, and that equals c. So you have x times this quantity. So what you're going to do is divide by that whole quantity on both sides. So here, those are the same. Top numerator, denominator, you have an a plus b, that cancels. So x is equal to c over a plus b. All right, in the next problem, we're solving for x. Now there's an x here, and there's an x here. So the first thing we have to do is isolate the variable term. Well, there are two terms that have the variable, so we want to get those on the same side. So let's subtract ab. So we have ax equals rx minus 2c minus ab. And now we need to bring rx to the other side. And those aren't like terms, so we just have to write them down. Ax minus rx equals minus 2c minus ab. So all that I really did in those two steps there is I got both x terms on the left side and everything else on the other. So now you have an x in both terms, so we have to factor it out. So if we take out an x out of the first term, you would have an a. If we factor out an x here, you would have an r minus r. And that equals minus 2c minus ab. We are solving for x. X is getting multiplied, so we do the opposite. We divide by a minus r, divide by a minus r, and you could put parentheses or you wouldn't have to. And those cancel, so x is equal to that right there. 2c minus ab over a minus r. All right, next one, we're solving literal equations here. So we have mostly just variables. So r is equal to capital BR times the quantity k sub 1 plus k sub 2 all over d. All right, so first of all, we're solving for k sub 1, which is here inside of this bracket. So let's multiply both sides by d to get rid of the fraction. So you have dr equals b little r. Here in this problem, the capital R and the lowercase r stand for different variables, so you have to distinguish between the two of them. And then the d's cancel, so you just have k sub 1 plus k sub 2. Now k sub 1 is what we're solving for, and that is in the parentheses. So the only way to get k sub 1 out is by distributing to get rid of the parentheses. All right, so now we distributed, so we have BR k sub 1 plus BR k sub 2. K sub 1 is what we're solving for. Remember our rules, isolate the variable term, so we have to get rid of the other term. So on this side, you have dr minus b lowercase r k sub 2 equals br k sub 1. So we want k1 by itself, so we're going to divide by br here. And remember what I said, you could either divide the whole side by br or to simplify even further. And it doesn't always work, but typically you can cancel something else. Divide every term by br. So the first term, nothing simplifies. Here, the b's cancel, the r's cancel. You have k sub 2, and that's equal to k sub 1. And that is your solution. All right, couple more here. So first of all, we're going to simplify each side. So combine like terms. 11 minus 7 is 4. And then we have 6x minus 3x. So really you just have 3x on that side. And when we subtract our variable, lo and behold, you'll find they cancel out. So it says 4 equals 5. Well, that's false. Anytime you're working a problem and you get a false statement, you would say there's no solution. And if you think about that, going back to this point right up here, You have 3x and 3x on both sides, so this will be equal. Well, if these values are equal, and one side is 4 and the other side is 5, you're not going to have an equality. So there's no solution when you have a problem like that. In the next one, combine like terms. So 4x plus 5 equals 4x plus 5. That's the same thing. Now, right at this point right now, if you realize you have the same thing on both sides, you could say, okay, x could equal 1 because 4 plus 5 is 9. 4 plus 5 is 9. X could equal 2 because 8 plus 5 is 13. 8 plus 5 is 13. X could equal 0, which would be 5 equals 5. There are infinitely many solutions. Because it's the same on both sides. Now, if you didn't recognize that right away and you just were solving, okay, oh, these cancel, you have 5 equals 5, true statement. So when you're solving and your letters go away and you just have a true statement, it means there are infinitely many solutions. Those are also called identity problems. All right, a word problem for you. Flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Palace in Brussels, Belgium, has a perimeter of 200 meters. So all the way around it measures 200 meters. What are the dimensions? So in a problem like this, we're given that here the length is x, the width is 3x. It mentions perimeter, so what you want to do is write down the formula. Perimeter is equal to 2 times the length, because you have 2 lengths, and 2 times the width. And then you substitute in all the values they give you. It tells you in this problem that the perimeter equals 200, and the length, we could call that x, and the width would be 3x. And now we solve that for x. So 200 equals 2x plus 6x. 200 equals 8x. So x would equal 200 divided by 8, which is 25. And to find your dimensions, then you have to substitute that back in. So this would be 25 right here, and this would be 75 right here. So you have 75 and 75 and 25 and 25, and that should add up to 200. All right, Celsius is equal to 5/9 the Fahrenheit temperature minus 32. We need to, what is F in terms of C? So we're going to solve for F. Now you have 5/9 times all of this. So in this problem, again, you have that fraction going on. Let's just get rid of that fraction. Multiply by whatever is in the denominator. So you have 9C equals 5F, oopsies, let me fix that. 5 times F minus 32. So we'll distribute. Let's see. 5 times 32, 160, I think. All right, now let's add 160 to both sides. So you have 9C plus 160 equals 5F, and we want to get the variable by itself. So we're going to divide both sides by 5, and to make it simplify it further, we'll divide every term then by 5. So you have 9/5 C plus 32 equals F. All right, let's do a distance type problem. 2 buses leave Dallas at the same time and travel in opposite directions. One bus averages 48 miles per hour, the other bus averages 42. When will they be 216 miles apart? It helps me to draw a picture when I do this. So we are at the bus stop. One bus goes one direction. So whatever this is the distance that it goes. So distance is equal to rate times time. The other bus goes the other direction. Whatever this is that bus's distance. Now we have probably two different distances because they're going at different rates. So let's call this distance 1, rate 1, time 1, because that's the rate of the first bus and the time of the first bus. We'll call this distance 2, rate 2, and times 2. Now, when we add this distance plus this distance, it is going to equal 216. So the distance the first bus goes will be its rate times time, right here. The distance the second one goes will be its rate times time. So let's fill in what we know. One bus averages 48, so that bus, the rate is 48. The other bus averages 42. And when will they be 260 miles apart? We don't know the time, so that's going to be t. That's our unknown. And so this is the distance of the first one. This will be the distance of the second. We want to add those together and have them equal 216. So 48t plus 42t equals 216. So we solve that. Let me grab my calculator really fast. So 48 plus 42 is 90. T equals 216. And divide by 90. You get T is equal to 2.4. And this was miles per hour, so that would be 2 4/10 hours would be your answer. That would be when they're 216 miles apart. All right, another problem for you. Two consecutive numbers add up to 287. What are the numbers? So you could sit and do guess and check on this. It might take you a while, but you could also solve this algebraically, which is pretty slick. Whenever you do problems that say consecutive numbers, the first one, you don't know what it is, so you call it x. The next one would be one more, so that would be x plus 1. So those are two consecutive numbers. They add up to 287. So just take the first number plus the second one, they equal 287. So 2x plus 1 equals 287, and we just solve. And divide by 2. So x equals 143. What are the numbers? Well, that is x is 143. The next one has to be one more. Now, if you add 143 plus 144, that gives you 287. The next one says three consecutive even numbers add up to 42. What are the numbers? Now, when you have even numbers, we have to be a little more careful. We can't just say x for the first one because x could end up being even or odd. And we want to force it to be even. So all even numbers can be divided by 2, or we would say they are divisible by 2. So we're going to write the first one as 2x. The next one is 2x, and think about how far apart are even numbers. You would have to add 2 to the previous one to get to the next even number. The next one, you have to add 2 again. So 2x plus 2 is plus 4. The next one would be 2x plus 6, and so on. But we only are they're asking us for 3 of them. So now we're going to add those together. And that will give you 42. Now we simplify like terms. So 2, 4, 6. So we have 6x takes care of the x terms, plus 2 and 4, which would be 6, equals 42. And we solve. All right, so x equals 6. So now you have to substitute that back in to see what the numbers are. So 2 times 6 would be 12. This would be 12 plus 2, which is 14. and this would be 16. Let's add those together. That gives you 30 plus 12 is 42. So that's your answer. So those are your numbers. Now, if they were consecutive odd numbers, the way that we force that to happen is we know that 2x is always going to be even. So if you add 1 to it, it would make it be an odd number. So your first odd number is 2x plus 1. The next one would be 2x plus 3. The next one would be 2x plus 5, and so on. All right, here we have volume equals 1/3 pi r squared h. Solve for r. No, write h in terms of v and r. Actually, we have to solve for h. We're going to solve for h. So first thing we're going to do is get rid of the fraction. So 3v equals pi r squared h. Now we have pi times r squared times h. We want h by itself, so we just divide by pi, divide by r squared. The pi's cancel, the r's cancel. So h equals 3v over pi r squared. All right, I'm going to go through and do a few more distance problems for you. Here we have 2 planes left in an airport at noon. One flew east, the other flew west at twice the speed. After 3 hours, the planes were 2,700 miles apart. How fast was each flying? So we don't know the rates. So again, I want to draw a picture. So this is distance 1, which equals rate times time. This is distance 2, which equals that plane's rate times time. So let's think here. What does it say? One flew east, the other flew west at twice the speed. Well, we don't know the rate of the first plane, so we'll call that just a plane R. And for the second one, we know that that was twice that rate, so we're going to call that 2R. And what was the time? After 3 hours. So both of them flew for 3 hours. So the time is 3 for each of them. And then those are their rates. They're written underneath. So the distance of the first plane, we could write it as 3R. The distance of the second one, we could write as 6R. And here's what we know about the distances. If you add them together, it equals 2,700 miles. So 3R plus 6R equals 2,700. So 9R equals 2,700. So R equals 300. So the rate is 300, and the other one was twice as fast, so the other one had a rate of 600. Here is a geometry problem. The length of a rectangle is 3 centimeters greater than the width. Okay, so this is the width. The length is 3 centimeters greater. We don't know, but we need to use the same variable, so we'll call this the width plus 3. And it says what the perimeter is 24. So again, it talks about perimeter. So perimeter is 2 times the length plus 2 times the width. The perimeter is 24. So 2 times the length, which is W plus 3, plus 2 times the width. And you can distribute and solve that. I just wanted to show you how to set that up. And that's it for this lesson. Let me know if you have questions.